All right, I wanted to do a quick little unscripted video about something I built to solve a problem that I have. Oftentimes when I'm counting components for the ADSB project, I'm measuring these out with a ruler, and it's kind of a pain in the butt, especially if this ends up being longer than one ruler's length, because then you're kind of measuring it out. You're like, oh, okay, that's one, and then you go again. Which hole was I at? You kind of miss it. So I wanted to build something that would count the number of components in an arbitrary length tape. And of course, it wasn't as simple as, just making something where you could fit just this size tape into, because there's also different pocket depths and different tape types. So this is like a white paper tape. And then this is like, a plastic tape that's transparent. You can see the pocket depths are much, much deeper just because these are large ceramic capacitors. And you've got, crazy pocket depths and widths like these electrolytic caps. And of course, the tapes get even wider than this. You have tapes like, up to this wide. I use them for like ESP32 modules and that kind of thing. There's been a couple of attempts at solving this before. I'd actually backed a project called Bean Counter that made a very nice handheld device that was sized specifically for 8mm paper tape like this. And it wouldn't work for these applications, but the majority of the passives I'm counting are something like this. And I was looking forward to that arriving, but it looks like they've stopped shipping them. So I figured it was finally time for me to build something myself and see how quick I could make something that would work. So this is what I came up with. It's terribly named. It's called the Dotterboard, like DOTTER board, because it counts dots essentially. And there's a little OLED at the top that'll show you how many components you've counted so far, as well as a little graphic of the tape. And you can increase the number of components per hole. So for instance, this is approximately 0402, where you have 2 components per hole. When you get to 1 component per hole, you're closer to something like this. I think these are 0805 capacitors, or yeah, they're 0805 caps approximately. And then there's a little encoder wheel on the inside. You can't really see it here. There's a blog post with all the files and everything, if you'd like to look at it. But there's essentially an encoder wheel in there that locks in with these little holes in the tapes. And then there's a little set of photo gates, 1 per encoder sprocket. And then there's 2 slot detectors, 15, or they're about 90 degrees offset in phase, not in, the actual absolute angle, but in the repeating angle of the angular difference between each encoder sprocket. They're offset 90 degrees within that small repeating angle. So it looks very slight if you look at the inside of this, but that allows you to get a nice gray code when you're pulling the tape through the encoder, and you can resolve the direction of movement as well as the number of ticks that you've actually moved. And then this is all being run in an RP2040 Zero module. Really cheap, and I've done some cursed wire wrap on the inside to avoid having to do a PCB, but I just wanted to show approximately how this works. So you'll look at the mechanical design of this, and it looks a little clunky. I mean, the height of this is mostly due to it being, wire wrap compatible, since there's some wire wrap pins in there for the back of the OLED and on the little microcontroller, and they didn't want them to touch each other. But we could make a PCB that would make this much shorter in the future. If you look at this lower section here, you're like, okay, why is this so much lower? Well, the reason is that, if we don't know the pocket depth of the tape. And so the encoder wheel obviously is in there, and this component could actually extend, much deeper than just the thickness of the tape. So for instance, these electrolyte caps, you can see how this would fit into the slot here without interfering. And then over here, there's also this little idler lever. So this is spring loaded and holds a bearing against the geared sprocket. And that just lets you really lock this in pretty nicely. And as an unintended byproduct that's quite nice, you hear a nice clicky, clicky, clicky sound as the actual bearing rolls onto the teeth of the gear. So let's go ahead and start with 1 component per hole. I think these are 0805 resistors. And we'll go ahead and put these in here. And you can see that as I feed through, I don't know if you'll be able to hear it, but you'll see it counting, and we get a count for the number of components on the tape. And if I press both buttons, it will reset that count. And then we can also try with the capacitors. So this should be 2 holes. Oh, let's see, it's 3 holes per component, I think. Yeah, that sounds about right. And then this one, I'll get the tooth locked into it. And I will start moving it along. I have a little Sharpie mark here to show where the actual index is for when I'm counting. So then I've moved it, advanced the component there. I will go ahead and reset the count. And we will go ahead and count. Okay, so that says 5, and we have 1, 2, 3, 4, 5. So that's pretty good. And then we've also got, this transparent tape. So another thing that some of the other designs do is they use a just a regular photo gate directly on the holes of the tape. And I haven't actually used many of them, so I don't know, but my intuition is that that might be difficult when you have different tape colors. So for instance, this is like a white paper tape, and then this is a clear plastic tape, and there's also black plastic tape. And so I want to dodge that whole thing, which was kind of the motivation for using the geared sprocket. So there we go. We'll go ahead and change this to, I believe, 1 component per hole. Yes. All right. And we will go ahead and engage that with the tooth there. And then I'm going to go ahead and reset the count. And then we will hit there. And if we want to be sure that this is working properly, another thing we do is just pull it backwards and verify that the count does, in fact, go back to 0. So that was the start position at 0. If I take it back one more, should see -1. Yeah. So that's a quick demonstration of the Daughterboard, as it's been terribly named. I hope that this might save some other people some time. This device has already saved me, I would say, quite a few hours, because I've already had to consign a few tens of thousands of components with it. All of the files for it are open source. Obviously, there's some little adjustments that can be made to the internals if we want to make this easier for people to make. If there's enough interest in the project, I'll go ahead and make a PCB for it. But in the meantime, I'd love to hear what you think. Again, the files are all open source. I'll link them in the video description and on my website. And if you'd like to discuss this design, you can join our Discord server at from the Pants for Birds website. So thanks very much.